The goal of video number 4 is to introduce issues related to validity of a study and experimental design and focus primarily on internal validity or threats to internal validity. So, the goal of internal validity is to examine whether or not the outcome or the dependent changes to the dependent variable can be a result of the independent variable. In order to be able to establish that cause and effect, we have to know that the cause precedes the effect, that the cause and effect are correlated with each other, and the correlation can't be explained by any other variable. Now, issues that can come into this can be measurement, based on measurement quality, reliability, and validity, as just described in those first 3 videos, but then sensitivity to individual differences, bias of the researcher, bias of the participants, and so on, cost and invasiveness, and then reactivity of participants. So there are a number of issues that can come into limiting whether or not you have cause and effect in a study. Now, when developing a theoretical or an experimental design, you want to make sure that you set things up very carefully in order to get you to that point. That means starting with a strong theoretical or scientific framework, so that all of the mechanisms are, the mechanisms come from a, solid background or base. You identify your participants or subjects with very clear inclusion and exclusion criteria. You develop the design appropriately. You control the independent variable heavily in order to determine cause and effect. You have solid measurement of the dependent variable, making sure your operational definitions are appropriate and that you have valid and reliable measures, that you use appropriate statistical analysis, and then you interpret it appropriately as well. So, internal validity, as I defined before, results can be attributed to the research design. Ultimately, we have good scientific control, extraneous variables have been controlled, and the treatment can be attributed to the dependent variable. In comparison, external validity is the generalizability of the results. Can we bring our results back to a larger population or bring them to the field? Often these are kind of sort of considered on a continuum where for every little bit that you give, or every part that you generalize, or you want to be able to generalize, you sort of have to give up control to get more external validity. Or if you add more control, you usually move away from external validity towards internal validity. Not always on a continuum. There are some things you can do to improve both internal and external, but for the most part, you're usually hurting, or you give up one to get the other. And it really is based on what your research question is. Based on your research question, your goal might be to have more internal validity or more external validity. This is based on whether you want to do more applied research or basic research. So here's a list of the major internal validity threats. We're going to go through each one of them. History are confounding effects of a specific event other than the experimental treatment that occur after the introduction of the independent variable. So as compared to an ANCOVA, where we are measuring the covariate prior to the administration of the experimental treatment, in history, something has occurred to our participants after the treatment has been introduced, and it confounds the study, and that's called a history effect. And this may occur for some or all of our participants. Confounds don't have to occur across the spectrum. They can occur, usually some of our participants are confounded, but not all, and that becomes a problem. Maturation deals with simply issues that occur because a passage of time. This is done in your more long-term studies. This might be training studies. This could be done in longitudinal studies, where you can just find that people change over a period of time, and as a consequence, outcomes aren't necessarily due to the treatment, but they're due to the fact that people change. Attrition can be another issue that has to deal with the change of time, where people drop out of experimental studies. Another name for this is subject mortality. It can be related to people passing away and thus far not being able to be part of the rest of your study, but can just, anytime a person drops out of your study, that would be considered attrition. And that can happen for non-random reasons. A friend of mine was in a study at UMass, a physiology study, where it was untrained females who had to come in and do 40-minute bike tests after having a supplement or a supplemental drink that was just apparently tasted horrible. And even though she was getting $60 or $70, and she was unemployed at the time, so the money was helpful. After 2 sessions, she dropped out because it was just so miserable. So that would be a non-random reason for her dropping out. It was due to the experimental study. Testing effects is concerned with the potential effect of pre-testing or repeated testing on a dependent variable. So the subjects may learn or increase performance based on simply having experience on the pre-test. So they sort of learn as a period of time. This is going to be close to the flip of a coin. Where here we're hoping or we're concerned that learning effects are going to hurt our post-test. There is also a reactive testing in the external validity that we'll get to that's an external validity threat. Instrumentation effects just goes back to everything we talked about in previous videos, where we're concerned with the reliability and validity specifically of our dependent variable, but making sure that all of our instruments and measurements are calibrated. Our administrators know exactly all the specific protocol, when to press go, when to start the stopwatch, and so on, to make sure our measurement is appropriate. Statistical regression, or regression towards the mean. This happens when groups are based on extreme scores and they're tested over time. We know that over time, those extreme scores will then start to work towards a middle score, just because on the way that people answer the same test over and over, they won't stay extreme. Differential selection. Every time you see the word selection, know that it has something to do with the sample that's being picked. Essentially here, would results have differed if you had used a different sample? This isn't so much a concern if you used random sampling, but if you use an intact or volunteer sample, even if everybody in your intact or volunteer sample met the same inclusion criteria and exclusion criteria, if you had used a different intact sample, would that have affected your outcome? And then we have a list of selection interactions. So these all have something to do with sampling, but then are mixed with either maturation, history, or instrumentation. Selection maturation is when experimental groups might experience maturation at different speeds, and that could come into play. History effects is when you usually deal with issues from different geographic regions or areas, where you're comparing groups from different areas, and now there's a confound in just where people live. Selection instrumentation is where errors in measurement may be different from extreme groups. This can create some floor ceiling effects, where a certain group is just going to score so low or score so high that you're really not getting to understand the full variance in that group. Now, on to other threats of internal validity. Validity of the measurement of the dependent variable. This goes back to our operational definition of the dependent variable does not actually apply to the real world, then how can we generalize? If validity is not well established, then what good is it? Experimental bias. Researchers may have certain expectations that influence how a subject responds. Experimenters may encourage subjects in an experimental situation, to work harder because they want statistically significant results. This can be unconscious or conscious. Obviously, we try to put it in procedures to not encourage our participants, but it happens. Expectancy effects. This occurs when a researcher anticipates certain participants will do better, and they sort of look for it in the results. Experimental treatment or diffusion occurs when the experimental condition is diffused to the control. In this case, people in the control group see what the experimental program is doing, and they try to do it themselves without being taught how to do it, and so they sort of pick up influence of it, and consequently it'll influence their outcomes on the dependent variable. The Hawthorne effect is named for a classic study performed in the 1920s at the Hawthorne Works, where researchers were interested in studying how various levels of lighting affected output of workers. So researchers found that no matter what they did, raise or lower the lighting, workers increased their productivity. Essentially, what this phenomenon found was that just by singling people out or giving them special attention by having them participate in the study, they performed better simply because they thought they were being watched. So just being evaluated usually makes people work harder. So even in dim lighting or a poor lighting situation, because they know they were being evaluated, they worked harder. That would suggest better outcomes than the dependent variable, and therefore the cause is the evaluation, not actually the independent variable. Compensatory equalization. This is when the experimental condition is desirable, so often researchers want to give the control group some compensation to equalize. Often this is unconscious, but they sort of help out the group or the control group without meaning to. Pretty hard to pick up or measure. You just sort of have to be really careful. This is where double-blind studies can be very helpful. Compensatory rivalry by the research group, also called the John Henry effect, is when participants in the control group feel left out or demoralized, so they try to sort of overcome that feeling by trying to outperform the experimental group. This is named after John Henry, who was a drilling worker who outperformed a drilling machine in a setting because he was aware his performance was being compared to that machine. Turns out my research methods class did a little extra reading on John Henry after I told him the story, and it turns out that after outdrilling the machine, he then soon after passed away as a result of how hard he worked. So the story didn't end very nicely. So in summary, threats to internal validity exist in every study. The ways that you can protect against these threats is through random assignment into the random groups, use control groups, establish the validity of our dependent measures. Threats like attrition, compensatory equalization, compensatory rivalry are not easily controlled for. This is where you really have to make sure all of your procedures and protocols are really clearly delineated. Using within subjects design kind of falls under control groups because you give people to be their own controls. Randomization, obviously, selective manipulation, identifying the groups and being very clear with what type of manipulation. Placebo, single blind, and double blind studies can also help in terms of limiting the diffusion across groups. And that brings us to the end of internal validity. In the last video, we'll cover external validity and statistical conclusion validity.